Hi GeoClass, this is lesson 3 in unit 2, and today we're going to talk about translations on the coordinate plane. So a translation is a shift or slide in which every point is moved the same distance in the same direction, and that's important. So it's a shift or slide in which every point is moved the same distance in the same direction. So I might be moving up, down, left, right. So I have two triangles here. I got the first one, ABC. Now that's my pre-image. That's the original. I know that because I just have ABC versus this one down here says A prime, B prime, C prime. So this one right there is the image. So this is my image. That's what it became. And this original one I refer to as my pre-image. And you can see that I shifted these. I want to describe how to translate ABC to its image, A prime, B prime, C prime. I didn't reflect it, I didn't flip it, okay, because the A is on the left and the B is on the right, and on the image, the A prime is still on the left and B prime is on the right. But I slid it over. So all you have to do is you're going to count. To go from A to A prime, I moved 1, 2, 3, 4, 5, 6, 7, 8 to the left, and 1, 2, 3, 4 down. So I moved 8 to the left and down 4. And it's going to be the same thing for B and C. I'm going to move 8 to the left and down 4. There's two ways that I can write this. Just like I use an R for a reflection, I use a T for a translation. And since I moved to the left, I'm going to do -8. If I was moving to the right, I would do positive. And I moved down 4, that's going to be -4. So that's one way to write it with the capital T. Another way to write it is just to write XY and then show the image. I take X and I subtract 8, and I take Y and I subtract 4. So those are the two ways to write it. We'll usually do it with the T just because that's a little bit easier and shorter to do, but if you ever see it written the second way, you won't be confused. So we got two questions. Is the size of the object preserved? Remember, preserve just means to stay the same, right? That's all preserve means. Does the size stay the same? Does the yellow triangle and the orange triangle look the same size? Absolutely. Is the order of the vertices the same? So now here's something new. Look at, if I was to go clockwise, all right, I start at A, the order of the vertices, if I'm going clockwise like this, goes A, C, B. And for the image, I start at A prime, and again I go clockwise, and it goes A, C prime, A prime, C prime, B prime. So yes, the order of the vertices stay the same. All right, a little bit of vocabulary that we got. First word that we have is isometry. And isometry is a transformation that does not change in size. So it's a transformation that does not change in size. Includes all of our rigid motions. So basically, rigid motion and isometry are very similar. Rigid motion is the new word that we are using. Isometry is the word that we used to always use. Rigid motion is a more common core word. Reflections are one type of rigid motion. Translations, which we did today. And rotations, which we will be doing in the next lesson. So an isometry is just a transformation that does not change in size. It includes all the rigid motions, our reflections, our translations, and our rotations. The only thing that it does not include, and this is more for another unit, is dilation. A dilation means to make something bigger or smaller, so that is not a rigid motion and it's not an isometry. A direct isometry, it preserves the size and the orientation. It preserves the size and the order of the vertices. What I was talking about up above with that going clockwise, ACB. So it preserves the size and the order of the vertices, and we call that the orientation. So a translation preserves the, I left some letters out on this one. A translation preserves the order of the vertices. That's the orientation. An opposite isometry preserves the size, because it is an isometry, but the order of the vertices change. All right, a translation, as we already saw up above, okay, the order of the vertices is exactly the same if I was to go clockwise. So a translation is a direct isometry. The order of the vertices is not changing. The size stays the same. A reflection, so if we look back, if you want to flip back to page 4, number 3, okay, that was an opposite isometry. I'll just draw it right here for you. But say I have a triangle, okay, and here's my original triangle, ABC, and if I was to flip it over this y-axis, the order of the vertices changes. Okay, in the original, if I was going clockwise, it's ACB, and on the new one, the clockwise is A prime, B prime, C prime. So the order of the vertices, the orientation changes. All right, using the same translation as the opening exercise, we're going to explore the path that the image follows. Using rays, we want to connect the pre-image points with the image points. What do you notice about the rays you've drawn? So let's go back up here. So I'm going to connect, let me just erase this right here. I'm going to connect the image and the pre-image. Just do this to get this all out of the way. All right. So let me get a nice red color so we can see. I'm just going to draw a ray connecting A to A prime. And if you have a ruler that you can use or a straight edge, that would be great. I'm drawing all these rays right here. Okay, so I connect the pre-image to the image. And the question is, what do you notice about these rays that they've drawn? These are all parallel to each other, and they also happen to be congruent. All right, so what do I notice about them? They are parallel and congruent. This ray is called a vector. A vector is a directed line segment, and this will be something that you do again in pre-calc. It's a directed line segment that has both length and direction. So just introducing you to that word vector. All right, so on the next page, I'm just going to draw the vectors that define each translation. And I'm going to assume that the pre-image is the one that is a regular line and the image is the dotted line. Okay, so I can connect any point to its image. There's my vector, and I just draw an arrow because the arrow shows the direction that it's going. I don't have to do every single point, I just have to do one. Like here, I could do here to here. And then here, I could do this to this. I'm just drawing a ray connecting the pre-image to the image. And then I'm going to write down my translation rule. Basically, if I have a point XY, the numbers next to the T tell me what to add to the X and the Y. The first number, the A, gets added to the X, and the second number, the B, gets added to the Y. But that's my rule for any translation. So let's do a little practice. Determine the coordinates of the image of the point 5, -3 under a translation of -2, -1. So basically I'm going to take 5 and I'm going to add on -2, and I'm going to take -3 and I'm going to add on -1. So that would result in 3, -4. Determine the coordinates of the image of the point -8, -3 under the translation. You're going to take the x, which is the -8, and I'm going to add 4. And I'm going to take the y, which is the -3, and I'm going to subtract 1. And again, my answer is -4, -4. So both of these questions, 1 and 2, are both translations, just different ways of writing them. 3 is a little bit different though. They want you to figure out the translation. Determine the translation that maps the point -5, 5 to the point 7, 1. So how did I get from -5 to 7? Well, I added 12. How did I get from 5 to 1? Well, I subtracted 4. And that's my answer. So this one was different and they already did the translation and you had to figure out the rule for it. A translation maps the point -2, 5 to the point -4, -4. What is the image of 1, 4 under the same translation? So basically I went from -2, 5 to -4, -4. You need to figure out the rule. What's the rule? How did I go from -2 to -4? Well, I subtracted 2. How did I go from 5 to -4? Well, I subtracted 9. Now I want to take this rule, this translation, and apply it to the point 1, 4. So I'm going to, what is the image of 1, 4 under the same translation, the same rule? So 1 plus -2 and 4 plus -9, because I'm using that same rule, and that would give me -1, -5. Okay? And then this last one right down here, translate the image 1 unit down and 3 units right, and then draw the vector that defines that translation. Okay, so I want to take every single point. I'm going to take point A, and I'm going to go 1 down and 3 to the right. So 1 down, 1, 2, 3 to the right. There's my new A. B, 1 down, 1, 2, 3 to the right. D, 1 down, 1, 2, 3 to the right. And C, 1 down, 1, 2, 3 to the right. I'm going to connect these, and I should have, a translation is a rigid motion. I should have the same figure, just shifted down, same shape, same size. I just shifted the position of it. Okay, and then I'm going to draw the vector. Vector, I can do it to any points that I want to. I'll just do right here. There's the vector that defines that translation. Okay, so we're going to practice.